the work energy theorem. Right, so we can define the work energy theorem as the work done by a net force on an object is equal to the change in kinetic energy of the object. We know this as the work energy theorem. So the equation then, the net work is equal to the change in kinetic energy. Now, let's look at why. Okay, so the work energy theorem. Now, just to prove that work is equal to the change in kinetic energy, we can use a bit of maths. Now, if we look at our normal work equation, force times displacement is equal to work. Now, if we take Newton 2, we know that force is equal to mass acceleration. So we can substitute this in, saying work then is equal to mass acceleration times displacement. Now, A and X, we can get that from kinematic equations, where the final velocity squared is equal to the initial velocity squared plus 2ax. So if we manipulate this round, we can get that to be vf squared minus vi squared divided by 2 is equal to ax. So if we substitute this in for ax over there, we can then get work is equal to mass vf squared minus vi squared over 2. Okay, so now we're going to multiply the mass in. So that means we will then get vf squared m minus vi squared m over 2. If we simplify this to look a little bit normal, we can then get half m vf squared minus half m vi squared. Now, are these ringing any bells? What you should see there is this is the same as saying ek final minus ek initial, which we can then simplify down to say work is equal to the change in kinetic energy. Okay, so we can then therefore expand this to say force times displacement is equal to half mass velocity squared minus half initial velocity squared times mass. Now, kinetic energy is increased when F net is in the same direction as x. So if we're pushing something forward, we're going to increase the kinetic energy. If something's already moving and we have frictional force acting on it, it will then decrease the kinetic energy, and so work would then get less.